Hello class, I'm working out of your Pre-Algebra book 5.1, Forms of Rational Numbers. To get started in defining a rational number, it's any number that can be written as a over b, where a and b are whole numbers, except b cannot be equal to 0. You cannot have several parts of a whole, as a fraction is parts of a whole, where there is no whole to draw from, a 0 in the denominator. But any other numbers work in the numerator and denominator. So a over b is a rational number. And then if we think of a rational fraction, it is a over b in lowest terms, and the GCF is equal to 1. B still cannot be equal to 0 in the denominator. So this is a rational fraction. All of that is fancy terminology for a fraction in lowest terms. For us to reduce fractions, we can use our knowledge of finding the greatest common factor to do that. So if you have a fraction at 12/18, then come over here and do some prime factorization for 12 and 18. So we're going to have 2 times 6, then 2 times 3. For 12, then for 18 we'll have 2 times 9 and 3 times 3. Remember, if we are looking for the GCF and we stack these prime factorization numbers, we can address the numbers that are common to both 12 and 18. 2 and 2, so we would have 2. 2 doesn't have a matching number in the factorization of 18 from 12, so we can't utilize that value, but 3 has a matching one, and there's an odd 3 left over. So we multiply the common factors in the prime factorization from 12 and 18 that we have in both numbers and multiply them together to be 6. What that means for our large fraction is we can divide the numerator and the denominator by the greatest common factor, and it'll reduce the fraction the fastest. So 12 divided by 6 is 2, 18 divided by 6 is 3. So using prime factorization and the greatest common factor of both 12 and 18, we can reduce our fraction all the way to its most simplified form. Let's try another one. We just have larger values here. We're going to take the prime factorization of 24 and the prime factorization of 90. We start with 2 times 12 over here. We'll get back to 24, and then we factor 12 out more. 3 times 4 for 12, and then 2 times 2. So we have 2, 3, 2, 2 for 24. And then for 90, 2 times 45. 45 is 3 times 15. 15 is 3 times 5. So 2, 3, 3, 5. Just stacking those to help we have a common prime factor of 2 in both numbers. We don't have any more 2's that are common. We have a common prime factor of 3 in both numbers here. And we don't have a common 5 in both numbers, so we leave that alone. We only have 2 and 3 that we can multiply to be common at 6. We have just found the greatest common factor of 24 and 90. That will reduce the fraction 24/90ths the fastest. Divide the numerator and the denominator by this greatest common factor that we found. We would get 4/15. That's our completely reduced fraction. If we're asked to rename a fraction that's improper as a mixed number, remember the fraction bar is a division symbol, and so we have 19/7, but we also have 19 divided by 7. So doing some work in the margin, 19 divided by 7. We're going to see how many times 7 fits into 19. Okay, that's 2 times. 2 times 7 is 14. 19 minus 14 is 5 for a remainder. The remainder is a part of the whole in our division, and so it is a fraction when we write it as a remainder, and when we rename 19/7 as a mixed number, our answer is our answer to the division problem with the remainder written as a fraction, 2 5/7. Let's try another one. For us to rename 12/8 as a mixed number, remember we have 12 divided by 8, so 12 divided by 8, 8 fits into 12 one time, subtract 8, and we get a remainder of 4/8. We can reduce the fraction 4/8 to 1 1/2. Remember, the whole number 1 is part of our value, so it needs to transfer across the equal sign. So our reduced mixed number that 12/8 is equal to is 1 1/2. All right, when you have a situation where you're given variables such as this expression y divided by 3z, you're asked to evaluate when y equals 38 and when z equals 2. We have this instruction evaluate. That means that you have to apply a couple of ideas. We're going to substitute the values of y and z, and then we're going to solve. That will follow the evaluate instruction. So when we substitute 38 in for y, we replace y. When we substitute 2 in for z, then I'll replace z. So this equals 38 divided by 3 times 2 is 6. And then we do some work in our margin, and we say we have an improper fraction, so we can say 38 divided by 6. Okay, I'm going to work this. 6 and 2 6. 2 6 reduces to 1/3. So our final reduced value is 6 and 1/3, written as a mixed number from the improper fraction. If we're asked to rewrite a mixed number as an improper fraction in lowest terms, such as 3 and 1/5, remember that we take 5 times 3 plus 1. So we can rewrite that over here across the equal sign. We will have 5 times 3 plus 1 on top, and our whole is 5 on the bottom, so we have a numerator and a denominator to work from. 5 times 3 is 15 plus 1, 16. Our whole on the bottom is 5. Our final value as an improper fraction is 16/5. Let's try another one. 7 and 6/8. To rewrite this as an improper fraction, we're going to take 8 times 7 plus 6 on top, the numerator, out of 8 as the whole. Will equal 8 times 7 is 56, plus 6 is 62, divided by 8. To reduce this, the greatest common factor is 2. We divide the top and the bottom by 2. And our final improper fraction in simplified form is 31/4. I hope this helps, and I'll see you soon.